Hello everyone, I'm Akash. In today's video, I'm going to solve an interesting question on group theory from recent TIFR 2024 exam. Question is, what is the least positive integer n greater than 1 such that x to the power n and x are conjugate for every x belongs to S11? Here S11 denotes the symmetric group on 11 letters and these are the options. We can solve this question in just 2 minutes by discarding the incorrect options. Okay. But in today's video, I will not just discard the incorrect options, but I will also prove the correct options. So let's begin the solution. Let x be an 11 cycle, say 1, 2, 3 and so on up to 11 belongs to S11. Clearly this is an element of S11, okay, and we know that k cycle has order k, so this implies and order of x is 11 because x is 11 cycle, okay, so its order is 11. So by definition of order of element in group, we have x to the power 11 is identity in S11, and we usually denote identity in symmetric group by this symbol, okay, that is every symbol maps to itself, that is 1 maps to 1, 2 maps to 2, 3 maps to 3 and so on, 11 maps to 11, okay. So x to the power 11 equals to identity in S11, okay. So this clearly imply x and x to the power 11 are not conjugate, okay. Why? Because we know a result that if alpha and beta belongs to Sn are any permutations, then alpha and beta are conjugate if and only if they have same cycle structure, okay. We will use this result. This result says that any two elements in symmetric group, here the symmetric group is S11, any two elements of S11 are conjugate if and only if they have same cycle structure. Clearly here x is 11 cycle, however x to the power 11 is not a 11 cycle, it is a product of one cycle, okay, it is a product of one cycle, it is nothing but 1, 2 and so on up to 11, okay, that is identity element in S11, okay. So clearly their cycle structure are different. So by this result, x and x to the power 11 are not conjugate element in S11, okay, are not conjugate element in S11. So this implies n cannot be 11 because question is x to the power n and x are conjugate for every x belongs to S11, okay, and so we have just considered one element this in S11, and clearly x to the power 11 and x are not conjugate in S11, so n cannot be 11, so option B is discarded, okay. Now let's consider x to be a 10 cycle, 1, 2 and so on up to 10. Clearly this belongs to S11, okay, and as it is a 10 cycle, so this, so order of x is, so order of x is 10, okay, because k cycle has order k, and so by definition of order we have x to the power 10 is identity element in S11, that is this. Okay, and again, as this is a 10 cycle and this is an identity element in S11, so clearly they have different cycle structure. So by this result, we have x and x to the power 10 are not conjugate element in S11. Okay, so this implies n cannot be equals to 10. Okay, so option A is also discarded. Okay, now let x be a 3 cycle 1 2 3 belongs to S11. Okay, here 1 maps to 2, 2 maps to 3 and 3 maps to 1, and rest of the symbols are maps to itself, that is 4 maps to itself, 5 maps to itself, and so on up to 11 maps to itself. Okay, then clearly here order of x is 3 because k cycle has order k. So order of x is 3. So by definition of order of element, we have x to the power 3 is identity element in S11. Okay. So from here, we can conclude that x to the power 12, which is nothing but x to the power 3 to the power 4, that is x to the power 3 4 times. Okay, and which is nothing but identity element operating itself 4 times, which is again identity element. Okay, so x to the power 12 is identity element in S11. So x and x to the power 12 have different cycle structure. Okay, what is the cycle structure of identity element? It is product of one cycle. Okay, 1 2 and so on up to 11, that is 1 maps to 1, 2 maps to 2, and up to so on 11 maps to 11. But here the cycle structure is different, 1 maps to 2, 2 maps to 3, and 3 maps to 1. Okay, so x and x to the power 12 have different cycle structure. So according to this result, they cannot be conjugate because any two permutation in Sn are conjugate if and only if they have same cycle structure. Here x and x to the power 12 have different cycle structure. So this implies x and x to the power 12 are not conjugate elements in S11. So this implies n cannot be equals to 12. Okay, so option C is also discarded. So we left with option D, and which is the answer. Okay, and in the next part of this video, I will prove that why n equals to 13 is the correct. So up to now, we have discarded these 3 incorrect answers and concluded that n equals to 13 is an answer. But why this is true? Let's see it. We will use these 3 results. Every permutation in Sn can be expressed as product of disjoint cycles. Okay, every permutation in Sn can be expressed as product of disjoint cycles. And the second result that we will use is disjoint cycles commutes. Okay, that is, if alpha and beta are any two disjoint cycles in Sn, then alpha times beta equals to beta times alpha. Okay, and the third result that we will use is if sigma belongs to Sn is a cycle of length k. Okay, if sigma belongs to Sn is a cycle of length k, that is k cycle. Okay, then sigma to the power I is k cycle if and only if I and k are relatively prime. Okay, if sigma belongs to Sn is a k cycle, that is cycle of length k, then sigma to the power I is also a k cycle if and only if this power, that is I and k, are relatively prime. Okay, so let consider x belongs to S11 be any element. Okay, then by this first result, x can be expressed as product of disjoint cycles. Okay, where sigma 1, sigma 2 and up to so on, sigma r are disjoint cycles in S11 of lengths k1, k2 and up to so on, kr respectively. Okay, that is sigma 1 is a cycle of length k1, sigma 2 is a cycle of length k2, and so on. Sigma r is a cycle of length kr, where these all sigma i's are disjoint cycles. Okay, now consider x to the power 13. Okay, so as x equals to this, so x to the power 13 will be power of this, that is sigma 1, sigma 2 up to so on, sigma r whole to the power 13. And as we know that disjoint cycles commutes, so this sigma i's commutes with each other. So this is nothing but equals to sigma 1 to the power 13, sigma 2 to the power 13, and up to so on, sigma r to the power 13. Okay, because disjoint cycles commutes. And we have seen the result that if alpha and beta are any two elements in Sn, then alpha and beta are conjugate if and only if they have same cycle structure. So from here we have x and x to the power 13 are conjugate in S11 if and only if they have same cycle structure. Okay, and this is if and only if x and x to the power 13 have same cycle structure, if and only if these independent cycles have same cycle structure, that is if and only if sigma 1 comma sigma 1 to the power 13 have same cycle structure. Okay, and sigma 2 comma sigma 2 to the power 13 have same cycle structure, and so on. Okay, that is sigma 1 and sigma 1 to the power 13 have same cycle structure, sigma 2 and sigma 2 to the power 13 have same cycle structure, and so on up to sigma r and sigma r to the power 13 have same cycle structure. Okay, now we will use the third result. So this is if and only if sigma 1 and sigma 1 to the power 13 have same cycle structure, means that they are cycle of same length. They are cycle of same length. But by third result, we know that sigma 1 and sigma 1 to the power 13 are cycle of same length if and only if k1 and 13 are relatively prime. Okay, because here we know that sigma I is a k cycle if and only if I and k are relatively prime. Here k is a length of sigma. Here length of sigma 1 is k1. So sigma 1 and sigma 1 to the power 13 is cycle of same length if and only if K1 and 13 are relatively prime. Okay, so this is if and only if GCD of K1 comma 13 is equals to 1 and GCD of K2 and 13 is equals to 1 and so on. GCD of KR comma 13 is equals to 1. Okay, and clearly this is true because 13 is a prime. So whatever the number here, GCD of 13 and K1 is 1 because K1 is KR is less than or equals to 11. Okay, these all KIs are less or equals to 11. KIs are length of the cycles, these cycles, and these cycles are elements of S11. So their length are less or equals to 11. So these KIs are less or equals to 11. So GCD of K1 and 13 is 1. GCD of K2 and 13 is 1. And so on. GCD of KR and 13 is again 1. So this is true. Okay. This holds. Okay. And as this is true, so this implies x and x to the power 13 are conjugate in S11. But x is any arbitrary element in S11. So we conclude that 13 is the least positive integer such that x to the power n and x are conjugate for every x belongs to S11. So this is the answer. Okay. Thanks for watching. There is a small announcement that we will soon starting 2 new batches for upcoming TIFR 2025 mathematics exam. One batch will be online and another batch will be offline. The details are as shown in the pics that you have seen in the middle of this video. These batches are regular batches, means that we will not only solve PYQs, but we will cover every possible theory and concept required to pass the exam. Moreover, we will not only solve PYQs from TIFR exam, but we will solve PYQs from other exams like CSIR, NET, GATE, NBHM, CMI, etc. And you will get detailed theory notes that are designed in a way that makes complex topics easier to understand. Moreover, you will get free test series. We will conduct 1 test per week and 4 full-length tests at the end of the syllabus. So if you are interested to join and to boost your TIFR preparation, then please contact us or WhatsApp us on below number.